Good day, future engineers. I am Shane Erica Dolendo. For today's presentation, I will be discussing about percolation. So let us begin. So first, we need to know what is really percolation. So percolation comes from a Latin word percular, to filter or to trickle through. Percolation is the movement of water through the soil, and it's a layer by gravity and capillary forces. So percolation theory is the scientific study of percolation that has provided a new knowledge and approaches to a wide range of issues in physics, material science, complex networks, and other areas during the last several decades. So basically, percolation is the process of a liquid slowly passing through a filter. So one example of these is the coffee percolation, where the solvent is the water and the permeable substance is the coffee grounds. And the soluble constitutes or the chemical compounds that give the coffee its color, taste, and aroma. Next example is the movement of weathered materials down on a slope under the Earth's surface. So basically, when the gravity alone causes the rock or the sediment to move down a slope, the erosion is called the mass movement. This process is also known as the mass wasting. And the prime moving force of groundwater is the gravity. So when the water that is in the zone erosion, where the air exists, is called the vadose water. And the water that is in the zone of saturation is called the groundwater. For all the practices, all groundwater originates as the surface water. So once underground, the water is moved by gravity. And the boundary that separates the vadose and the saturation zones is called the water table. Usually, the direction of water movement is changed from downward, and the horizontal component to the movement is added that is based on the geologic boundary condition. So in the geologic formation in the Earth's crust serves as the natural subterranean reservoirs for storing the water. Others can also serve as the conduits for the movement of water. So essentially, all the groundwater is in the motion. Some of it, however, is moves extremely slowly. And a geologic formation which transits the water from one location to another in a sufficient quantity for economic development is called the aquifer. So therefore, the movement of water is possible because of the voids or pores in the geologic formation. So some formation conduct water back to the what we call groundwater. So a spring is a place where the water table reaches the ground surface. So stream channels can be in contact with an unconfined aquifer that approach the groundwater the ground surface. So the water may move from the ground into the stream or vice versa, depending on the relative water level. So the groundwater discharges into a stream, forms the base flow of stream during dry periods. So especially during droughts, an influent stream supplies water to an aquifer while influent streams receives water from the aquifer. So let's proceed. So what is percolation rate? So percolation rate means the time expressed in minute per inch required for water to seep into saturated soils at a constant rate during a percolation test. So basically, it is a speed of water that percolates on the geologic forms. The percolation rate is calculated by the magnitude, calculated for each test hole by dividing the time interval used between measurement by the magnitude of the last water drop. So this calculation will result in a percolation rate in terms of minute per inch or minute per centimeter. So a percolation test, or what we call perk test, determines the rate of water absorption into the ground. So the procedure measures how long it takes a measured amount of water to drain away from a saturated hole dug into the ground, and the result determines the suitability or the permeability of the soil, and it indeed ensures that the ground has sufficient drainage capacity to handle the amount of water that will come from the drainage field you intend to install. So for the preparation, we need to determine where the tank will be situated first, and where the outlet pipe is likely to be, and where the drainage field is likely to start. So we need all of these materials, such as shovel, a tape measure or a ruler to measure at least 300 mm. A way to measure time in seconds is we need a stopwatch or a timer, and also a notepad and pen or something to record the results, and lastly a bucket or a hose pipe to put water into the dug hole. So next is, what are the steps in determining the percolation test? So the test itself is fairly simple, I can say, because we need to dig a hole in a certain size where your drainage field is going to be. And we need to fill it with water and see how long it takes for the water to disappear. So to get the most accurate result and do the test right, there's a bit more devil in the detail. So So here are the steps in determining the percolation rate. So first is we need to dig the hole. So make out a test hole that is 300 mm by 300 mm wide and at least 300 mm deep below the proposed invent level or the outlet pipe. So the test hole must be below in the invert level. Where the invert level is quite deep, you may need a you need to excavate a larger area to safely reach the outlet pipe depth. Next is we need to saturate the soil. So clear the hole of any loose debris, including stones or lumps of soil, and use your measuring tape or ruler to mark out a depth of 300 mm inside the test hole and fill the hole up to this 300 mm depth mark. So it will allow this water to seep away overnight. So note that if you already think your soil might be too porous or too dense, and you don't want to wait overnight, then the following guidelines should give you a faster answer. So this is the answer. If the water drains away too quickly, you need to refill it several times and monitor the rate at which it soaks away. So if it is continuously draining away within 10 to 20 minutes, then the soil is unsuitably for a drainage field. So as it is too porous or it is too dense, alternatively, if you find the water that hasn't drained away within 6 to 12 hours, that means that your soil is too dense and therefore also unsuitable. So in either event, the test has failed and it will be unnecessary to continue the further steps. So the next step is to determine the percolation rate. So in the next day ahead, you need to refill the test hole with water again up to a depth of 300 mm and observe how quickly the water seeps away. So when the water level drops to a 225 mm or 3/4 full, you need to start timing in seconds and observe how long it takes the water level to reach the 75 mm or the 1/4 full. Then it will give you the time it took the water level to drop 150 mm. So you need to divide this number by 150 to determine the average time it takes the water level to drop 100, level to drop 1 mm. So this is called the VT number. So for example, if it takes 1 hour for the water level to drop 150 mm, then the calculation would be 60 minutes times 60 is equal to 3,600 seconds. So 306 so 3,600 divided by 150, it will result to a 24 seconds, or that is your VP number or VP value. So the last step is you need to repeat again the test. So step 1 to 3 should be carried out at least 3 times per test. So preferably at different times of a day. So the average VP number or VP values across all tests performed should then be taken as a percolation rate of your soil. So if the VP number or VP values vary widely between your tests, then you should consider performing the test a further 3 times in different locations. So this will help your average to figure out if it is accurate as possible. So um, So by interpreting the result of your percolation test, your average VP number is between 15 to 100, then that's right, you can have your soak away filled. So a minimum value of 15 ensures that your soil's percolation rate is slowly enough to allow the influent to be sufficiently treated before reaching the groundwater. So any value lower than 15 would mean that the untreated influent could drain away too rapidly and pollute the groundwater. So a maximum value of 100 ensures that the soil's percolation rate is quick enough to allow the influent to disperse into the ground and avoid the system of failing or backing up. So any value higher than 100 would mean that the untreated influent would not soak away fast enough for your system to be effective. So armed with these informations that I said a while ago, assuming your tests have been a success, then you can now go on determining the most suitable size of drainage field for your foul water system. Advance to my sizing aseptic drainage field advice. Then if you are not unsure about your result, you have any other questions or queries, you can always it is always worth seeking expert advice. So I can suggest you can ask in JDP, or they have a technical support team who are always ready to offer free and impartial advice about this system. So next is, why do we need a percolation test? Basically it makes sure that the sockaway is going to work properly or isn't going to pollute the environment. So a percolation test doesn't just test the solubility and the permeability of the soil for your sockaway, but it also checks the drainage field that will allow to discharge your sock into the soil. So without pulling or saturating the ground at a rate that fully removes contaminants before it reaches the water table. So when is a percolation test needed? So a percolation test should always be performed before installing a new sockaway system or when replacing an existing one, which is usually sited on a different location or site to the existing sockaway. So if you are installing a new septic tank or a sewage treatment plant, and or depending upon a drainage field to be your discharge option. So if you so then you must perform the test. And then next is where to perform a percolation test. So percolation test should be performed on a site where you want to install a drainage field or with at least two separate test holes. So for the foul water drainage field system, you need a minimum of 10 meters away from any water course. So a 15 meter away from any building, the 50 meters from any water supply. So for example, if you have a garden that is measured 50 meters, then the percolation test result show your drainage field would also need to be 50 meters. Be you would be unable to install it due to these minimum distance requirements. So this is why the percolation test should be conducted during the early stages of your planning permission journey. So to be able to further understand the steps, let's watch this. So that's it for my report. Thank you for listening and God bless and stay safe, everyone.